there! In this kind of videos I would like to cover the statistics that important for the biologists, so please enjoy the video. Welcome to my adventure. Today we'll learn what is the difference between units and dimension, illegal data manipulation, and how to choose your decimals. It could be as straightforward but with a trick. So let's start with arbitrary standards. The magnitude of all quantities rely on a comparison to an arbitrary standard. In other words, we need a standard or a point of reference to measure and make sense of the magnitude of any quantity. Without a defined benchmark, it becomes difficult to assess the significance or scale the particular quantity we are interested in. And the chosen standard acts as a basis for making meaningful measurements and comparisons in the world of biology and statistics. For example, we all know temperature, and we all know that temperature is measured in centigrades or Celsius in our day-to-day life. At 0 it's solid, and at 100 it boils and becomes in the vapor, in the form, gas form. So obviously at standard pressure and equilibrium. And this is the arbitrary standards that all of us know. And this brings us to dimensions. There are 5 simple dimensions that can form different quantifications, such as length, mass, temperature, electrical current, and time. And as you already may figure this out, units are not the same as dimensions. For example, length. You can measure length in different ways, using meters, inches, miles, elbows, fingers, rock. It's really limited to your imagination. And this brings us to which units to use in our data analysis. Long time ago, people agree on so-called SI units, the International System of Units. SI units are the standard set of units used worldwide for expressing a physical quantity. And SI system was established to provide kind of a constant framework for scientific measurements, and it's based on 7 basic units, important, from which all other units can be derived. And here is those units. Meter to measure the distance or displacement, kilograms to measure the amount of the matter in the object, seconds to measure the duration of the event, ampere to measure the flow of electrical charge, kelvins to measure temperature, and mole to measure the quantity of a chemical element or the compound, and candela to measure the brightness of the light source. And as I have mentioned before, base units can be used together to form other units, derived units, such as square meters for area, cubic meter for volume, meter per second for speed. And as you can see, SI system is widely used in science, engineering, and other disciplines for its simplicity and global acceptance. And note, the word pair here, or a slash, means division, and it can be represented as a negative superscript, which is an example here, ms -1. And the same thing can be done to any other combined units, which we divide on something. For example, let's say cells per milliliter. So we also can show it in the cells per milliliter in -1. So any quantity consists of the number and the unit. And ideally it should be used as SI units, but however, whatever units you use, just keep them the same, because only quantities with the same units can be added and subtracted. And the numbers representing ratios, percentages, or log, so-called dimensionless numbers, and they don't need a unit. We also can represent the quantity with the letter or a symbol, and here in algebra the quantities that are changeable are the variables, and the quantities that are unchanged are the constants. For example, let's take a simple example of how to find a volume of a sphere. So to find the volume of the sphere, we all know we need to divide 4/3 times pi times cubic r. And the variable here is the r, and the constant here is pi and 4 divided by 3. Very simple. Let's talk a little bit about simple algebra manipulations that we can do and all of us know. Addition. A plus b the same will be as b plus a. Subtraction. A minus b will be the same as a plus negative b and the same as negative b plus a. Multiplication. When we have a times b, it's the same as b times a, and it can be represented without any sign like ab, and depends on what country we're learning math, it can be represented with a dot instead of x. And division. A divided by b will be like a as a slash b as the previous example, and it also can be written as a times 1 divided by b. So let's recap some rules. Very simple ones. When we multiply two positive, we will get positive. It's the same as we're representing a times a will be a squared. When we multiply negative, we again get positive, and it can be represented as a. Negative a times negative a will be a squared. And only when we have one negative and one positive and we multiply them together, we get negative. And when we show this example is a negative times a will be minus a squared. And let's talk about brackets. When we have a minus brackets b plus c brackets will be the same as a minus b minus c. In example, for example, 5 minus brackets 1 plus 2 will be, if we open it, will be 5 minus 1 minus 2. So we can see that we have two negative, and it also can be written in 5 plus negative 1 plus negative 2. A story changes when we have a plus b and then it's a negative c. So the brackets goes first, and then we have a plus b minus c. And in this example, 5 plus 1 brackets minus 2 will be 5 plus 1 minus 2. As you can see here, is only one negative. It will be 5 plus 1 plus negative 2. And a common factor. In this simple example, 3 times a plus 9 times b, we can see that all of them could be divided by 3. Therefore, we also can multiply them by 3 and removing the rest of the equation into the brackets, as it's shown here. 3 times in the brackets a plus 3b. And similar with the equations x times y minus y, and y here is the common factor, and it also can be moved outside the brackets and keep the rest of the equation inside. But how would you open the brackets? Everything in one bracket is multiplied to everything in other bracket. Very simple. Let's take an example where we have one bracket x plus 2y plus 4 and it's times another bracket 2 plus 7x. We will get something like this, where x times 2 will be 2x, x times 7x will be 7x squared, 2y times 2 will be 4y, 2y times 7x will be 13xy, 4 times 2 will be 8, and 4 times 7x will be 28x. We can see that 24x and 2x has a common factor, so we can add them together. And this is how we will get our formula. How to transpose our formula? If an equation is rearranged, all what is done to one part need to be done to other part of the equation. So in this example where we have starting with x equal to y plus a and we want to remove a, we need to do the same thing to one part and to other part, and we'll get something like this: x minus a equal to y plus a minus a. So this is subtracted and we're left with x minus a equal to y. In this example we want to divide or multiply, we do exactly the same. So we need to divide here by 2 to remove 2 from this part of the equation. And we end up with x minus a divided by 2 equal y. Or we can say y equal x minus a in the brackets divided by 2. So it is the same. So you can see that we all of the equation divided by 2. Here it was a common factor too, so we removed it. Let's talk about fractions. Fraction may consist an algebraic expression in the form of numerator and denominator. In this example, a numerator is x divided by xy minus 2x, which is a denominator. In this example, we can see that x is the common factor for both of them. So to remove it, we need to move x outside the bracket so we can have a multiplication. So x in a numerator and x times brackets open y minus 2 brackets close is again denominator. And now we can remove the x's. When we remove the x's, we end up with 1 divided by x minus y. So to see the formula, the equation is simplified to this form. How to multiply and divide fractions? It's again very straightforward with multiplication. As you can see here, a divided by b times q divided by z. As we see them, we multiply them. So we will get a times q divided by b times z. With a division, it's a little bit more trickier, where we have a divided by b divided by q divided by z. To do so, we need to flip it here, and we will get a divided by b times, so you can see the sign has changed, z divided by q. So we can see that a numerator here become denominator and a denominator become a numerator. And now we have a multiplication, and we can multiply it straightforward. And we get a times z divided by b times q. But how would we subtract and add the fractions? And again, to do the subtraction or addition, we need to get an equal denominator. As you can see in this example, they have different denominators, a divided by q and b divided by z. So to do so, we need to multiply opposite denominator to an opposite numerator, like this. As you can see here, the a times z and q times z. And other part, we b times q and z times q. So you can see that this part is multiplied by this part, and this part is multiplied by this part. So here we now have an equal denominator, and we can add them together, and we will get az plus bq divided by zq. Let's talk about my favorite topic, decimals. Decimals are the way of representing numbers that fall between the whole numbers. And they are represented in the points and used to separate the whole number part from the fraction part of this number. For example, 10 divided by 2 will be 5.0, so here the whole number is 5 and its fraction is 0. And this is the first decimal. In this example, 1 divided by 3, we can see that it will be 0.333 to infinity. So the decimal points are stretched to infinity. And here, 1 divided by 4 will be 0.250. So 0.250. And here is only 3 decimal points. To round the decimals, or rounding a decimal, is a process of approximating a decimal number to a specific number of a decimal point. All following numbers are rounded to a higher number if it's bigger or equal to 5. And if it's less, it stays unchanged. In this example, I'll show what I mean. For example, we need to round it to a fifth decimal, or given that we need to round it to a fifth decimal. In the first example, we see that 10 divided by 2 will be 5.0, and here we need to extend the decimals to get the 5 decimals. 5.0000, which is 5 decimals now, and in imaginary we have a 6 decimals, which also will be 0, and it's less than 5. Therefore, it stays unchanged for the 5th decimal. In this example, 1 divided by 3 will be 0.3 to infinity, which is shown here with brackets. So it's 0.3333, and again the 6th decimal over here will be 3, and 3 is less than 5, and therefore the 3 on the 5th is unchanged. Similar to the 3rd example. But the story changes when we need to round to the 1st decimal. With the 1st example, it's unchanged, 5.0 stays 0 because it's the 1st decimal, and the 2nd decimal is 0. With the 3rd example also there is no big change. But with the 3rd example, when we have 1 divided by 4 will be 0.250, we can see that the 2nd decimal is 5, and it's equal to 5. It means that the 1st decimal need to be increased, and it will be 0.3. And this brings us to how to choose a right decimals. And it's really based on the sensitivity of your machine. For example, let's take a ruler, a normal school ruler, to measure the length of the leaf. The smallest division of our ruler is 1 millimeter, so our precision is to 1 millimeter, and we cannot go below 1 millimeter. So it's just not suited for our ruler. It cannot measure something between a millimeter or go into micron scale. And this really becomes important when you do your measurements and your data representation. For example, let's measure a leaf, and our first leaf is 30 millimeter, the second is 20, and the third is 11. And this brings us to the 3 technical replicates. So we need to find a mean, and it will be our mean of the first biological replicate, which will be 23.3333 to infinity of the millimeter. And this is correct mathematically, but incorrect biologically. Because we cannot represent our answer as the 20.3 millimeter, as our machine, our ruler, is not suited to make this judgment. So what we can do is to show the results only at millimeter scale. So we need to round our results to present it to the reader. And I so called it an assumption mean. So it will be 20 millimeter because 3 is less than 5. And here where people can be confused. For example, let's take extra 2 biological replicates where we get 20.8 and 20.4, and we want to find the mean of whole experiment. And you would use an assumption mean for all of them because we can measure with the ruler. So 20 plus 21 plus 20 divided by 3 will be 23.33, and to round it, it will be 20. And here is the error where it's rise. We cannot use the assumption mean in our calculations because it will rise an error. We always need to use a mathematically correct means in your calculations, because when you would use the mathematically correct means, you will get a different answer, 20.5. And here is the thing, 5 is equal to 5, therefore it can be rounded to a higher number. And this will bring us to results 21 instead of 20. And this is the correct way of representing your data because you was using the ruler. But how to sum a decimals? And when you have an example where you use 2 different machines with 2 different sensitivity levels, for example, you use a ruler or something more sensitive than a ruler. And here the simple answer is to stick to the less sensitive machine as your limit for your decimals. For example, our first measurement was done with the ruler and the leaf was 50 millimeters. Because the sensitivity of our measurement is 1 millimeter, we cannot go below that. And the second measurement was done with the laser, and we can go to the lowest point as 1 micron. And it will give us 3.123 millimeter. So we can see that we go below the millimeter scale. And when we will find a biological mean, it will give us 26.5615. And it's again correct mathematically, but biologically incorrect. And you may think that the right answer to representing your data would be 26.562 because the fourth decimal is 5, and therefore to stick to the 3 decimal it will be 3. But actually the right way to representing the data is again to stay to the less sensitive machine you use to measure it, because we cannot judge on what was here after 1 millimeter. Therefore the right answer will be 27 because the 5 here is equal to 5, and this can be changed to 7. I hope you have enjoyed this video, so please press the like button, subscribe and share this content with friends, and stay connected, and see you next time.